The most commonly used disk arrangement is a simple volume. This volume is a contiguous, unallocated area of a physical hard disk that you format to create a file system. You then assign a drive letter to it or mount it in an existing volume by using a volume mount point. Simple volume characteristics. A simple volume is a volume that encompasses available free space from a single, basic, or dynamic hard disk drive. A simple volume can consist of a single region on a disk or multiple regions of the same disk that link together. Simple volumes have the following characteristics: not fault tolerant. Disk failure leads to volume failure. Volume I/O performance is the same as disk I/O performance. Simple volume scenarios. The following table contains example scenarios for disks and volumes. Scenario. Description. Business desktop computer with one disk. Most business users require a basic disk and one basic volume for storage, but do not require a computer with volumes that span multiple disks or that provide fault tolerance. This is the best choice for those who require simplicity and ease of use. Business desktop computer with one disk and more than one volume. If small business users want to upgrade their operating systems and reduce the impact on their business data, they must store the operating system in a separate location from business data. This scenario requires a basic disk with two or more simple volumes. Users can install an operating system on the first volume, creating a boot volume or system volume, and use the second volume to store data. When a new version of an operating system releases, users can reformat the boot or system volume and then install the new operating system. The business data located on the second volume remains untouched. A simple volume might provide better performance than striped data layout schemes. For example, when serving multiple lengthy sequential streams, performance is best when a single disk services each stream. Workloads composed of small random requests do not always result in performance benefits when you move them from a simple to a striped data layout. The emergence of SSDs, which offer extremely fast data transfer rates, offers the Windows user another decision related to storing data. SSDs currently are more expensive and have smaller capacities compared to traditional magnetic hard disk drives. This combination of performance, size, and cost is an acceptable compromise when used in small form factor devices. However, a desktop PC might benefit from a combination of an SSD for Windows system files and a large capacity hard disk drive for business data. Compare mirrored, spanned, and striped volumes. In addition to simple volumes, disk arrangements also support the following volume types. Mirrored volume. A mirrored volume presents two disks to the operating systems as a single logical volume. A mirrored volume always consists of exactly two disks. Each disk has an identical copy of the data that is on the logical volume. Spanned volume. A spanned volume joins areas of unallocated space on at least 2 and at most 32 disks into a single logical disk. Striped volume. Similar to a spanned volume, a striped volume also requires 2 or more disks. However, striped volumes map stripes of data cyclically across the disks. Basic disks support only primary partitions, extended partitions, and logical drives. To use mirrored, spanned, or striped volumes, you must convert the disks to dynamic disks as described previously. Dynamic disks use a database to track information about the disk's dynamic volumes and the computer's other dynamic disks. Because each dynamic disk on a computer stores a replica of the dynamic disk database, the Windows operating system can repair a corrupted database on one dynamic disk by using the database on another dynamic disk. Mirrored volumes. A mirrored volume also is a RAID 1, redundant array of independent disks, volume. A mirrored volume combines equal-sized areas of unallocated space from two disks. You use a mirrored volume when you wish to provide redundancy for your system partition. Both spanned volumes and striped volumes require a Windows operating system to be running to recognize the volume. Therefore, neither of those solutions can provide protection against disk failures for a system partition. When creating a mirrored volume, the disk for the shadow volume must be at least the same size as the volume you want to mirror. Once you establish the mirror, you can't resize the mirrored volume. There are two main benefits of using mirrored volumes. Recovering from a disk failure is very quick as there is no data to rebuild. Additionally, read operations have a slight performance boost because you can read from both disks simultaneously. There are two main disadvantages of using mirrored volumes. Write operations are slightly slower as every write needs to occur on both disks. Mirrored volumes are the least efficient use of space compared with other disk configurations. Spanned volumes. A spanned volume gives users the option to gather non-contiguous free space from two or more disks into the same volume. A spanned volume does not provide any fault tolerance. Additionally, because the areas that you combine are not necessarily equally distributed across the participating disks, there is no performance benefit to implementing spanned volumes. I/O performance is comparable to simple volumes. You can create a spanned volume by extending a simple volume to an area of unallocated space on a second disk, or you can designate multiple disks during the volume creation process. The benefits of using spanned volumes include uncomplicated capacity planning and straightforward performance analysis. If you create a new spanned volume, you must define the same properties as when you create a simple volume in terms of size, file system, and drive letter. In addition, you must define how much space to allocate to the spanned volume from each physical disk. You can create spanned volumes on dynamic disks only. If you attempt to create a spanned volume on basic disks, the Windows operating system prompts you to convert the disk to dynamic after you have defined the volume's properties and confirmed the choices. It is possible to shrink a spanned volume. However, it is not possible to remove an area from a specific disk. For example, if a spanned volume consists of three 100 MB partitions on each of three disks, you cannot delete the third element. If you install additional hard disks, it is possible to extend the spanned volume to include areas of unallocated space on the new disks, as long as the total number of disks does not exceed the 32-disk limit for spanned volumes. Striped volumes. A striped volume is a RAID 0 volume. A striped volume combines equal-sized areas of unallocated space from multiple disks. You should create a striped volume when you want to improve the I/O performance of a computer. Striped volumes provide for higher throughput by distributing I/O across all disks that are a part of the volume. The more physical disks that you combine, preferably across several disk controllers, the faster the potential throughput is. For most workloads, a striped data layout provides better performance than simple or spanned volumes, as long as you select the striped unit appropriately based on workload and storage hardware characteristics. The overall storage load balances across all physical drives. Striped volumes also are well suited for isolating the paging file. By creating a volume where page file sys is the only file on the entire volume, the paging file is less likely to become fragmented, which helps improve performance. Redundancy is not required for the paging file normally. Striped volumes provide a better solution than RAID 5 for paging file isolation. This is because the paging file activity is write-intensive, and RAID 5 is better suited for read performance than write performance. Because there is no allocated capacity for redundant data, striped volumes do not provide data recovery mechanisms such as those in RAID 1 and RAID 5. The failure of any disk would result in data loss on a larger scale than it would on a simple volume. It disrupts the entire file system that spreads across multiple physical disks. The more disks that you combine in RAID 0, the less reliable the volume becomes. When you create a striped volume, you define the file system, drive letter, and other standard volume properties. Additionally, you must define the disks from which to allocate free space. The allocated space from each disk must be identical in size. It is possible to delete a striped volume, but it is not possible to extend or to shrink the volume. Note: RAID 5 is a striped set with parity volume. It combines the speed of striped volumes with fault tolerance. It isn't possible to create RAID 5 in disk management in Windows Client. A similar configuration can be achieved using storage spaces.